lifting capacity of gas filled volume or payload. So today our lecture is this one, payload or lifting capacity of gas filled volume, because this is given in the NCERT also as well as competition examination also, and question is also asked. What is lifting capacity? It's very clear that when gas is filled in the balloon, then balloon goes up in the sky. So what happened to why it is balloon is going up in the sky? Because of the payload of the balloon. We'll see what is the meaning of payload. When balloon is filled with a gas lighter than air, then it rises up. Why? Because due to the difference in the density of the gas and air. So if the density of the gas is lighter than air, therefore it will go. That lifting capacity of hot air is called as hot air or light gas balloon is measured as a payload. Higher the value, more is the lifting capacity. If the value will be higher, then the lifting capacity will be more. So we can write in the form of equation also, payload or lifting capacity is equal to mass of air filled in balloon minus mass of the gas filled in the balloon at the same pressure and temperature minus mass of the balloon. This is the equation. This is the total mass of the air filled in balloon divided by mass of the gas, mass of the balloon. This is called payload. Or another equation is mass of the air displaced by balloon minus sum of the mass of the balloon plus air filled in it and other mass, if any, is there. This is also called as payload. So let us take problem to understand this thing. Determine the payload of balloon of volume 10/6 liter filled with helium gas at 27 degrees centigrade and 1 atmospheric pressure. Assume that balloon is massless and the molecular mass of air is 28.84 AMU. So this is the molecular mass of the air. So payload is given here. So first we have to find mass of the air filled in balloon. So mass of the air filled in balloon is PV equal to W by M into RT. So this is the weight of the air. The weight of the air will be PVM by RT. So again pressure is given here, 1 atmospheric. So volume is 10/6. You can see this volume 10/6, and again mass is given 28.84. This is the gram and RT. So we'll get 1172.3 kilogram. Now this is the air. Now mass of the helium. So what is the mass of the helium? With the same equation, weight of the helium by PVM by RT. So this is the pressure, volume, mass of the helium, RT, 162.6 kilogram. Now we know the weight of the helium also. Now we know the weight of the air also. The mass of the balloon is, they have given, negligible. So what is the payload? So using the formula, mass of the air minus mass of the helium, mass of the balloon. So this is the value, air, helium, mass of the balloon 0. So we will get 1010. This is the payload of the balloon. So this is easy question. You can see some other question. Calculate the payload when a balloon of radius 10 meter and mass of 100 kilogram is filled with helium at 1.66 bar at 27 degrees centigrade. Density of air given 1.2 kilogram per meter cube and R is 0.083 bar dm cube per Kelvin per mole. So again you can see this is the payload. What is payload? Payload is the mass of displaced air minus mass of filled balloon. So this is the actually formula, mass of displaced air minus mass of filled balloon. So what is the mass of displaced air? So again volume of displaced air into the density of the air. So this is the volume of balloon into density. So what is the to find the volume we require radius. Radius is given here 10 meter cube. So this is the volume of balloon into density 1.2. Solve it, you will get the 5028.6 kilogram. This is the mass of displaced air. What is the mass of filled balloon? So for filled balloon, air is inside this balloon. So we have to take out the mass of the filled balloon. So mass of the helium in balloon will be your PV by RT by PVM by RT. So pressure is given here 1.66. Volume is given here 4190, that we have already calculated, 4 by 3 pi r cube. So 4190.5 is the volume and R is the mass of the helium divided by RT. So we will get 117.48 kilogram. So mass of the filled balloon will be, this is the mass of the weight of the helium, this is the mass of the balloon 100 kilogram. So add it, this will get, what is payload? Payload is the mass of the displaced air, that was displaced air, minus mass of the filled balloon with mass of the balloon. So we will get this is the payload. This is our answers. Now let us see, there is one more laws that we left behind after the this one previous topics. This is one more topic left behind, that is called Amagat's law of partial volume. So this law is just analogous to the Dalton's law of partial pressure. So analogous law of partial pressure, if you remember Dalton's law of partial pressure, that is the partial pressure of the gas is equal to mole fraction into total atmospheric pressure. So in the similar analogous, we can use the law of law of partial volume. So according to this, at the constant pressure and temperature, total volume of the gases mixture is equal to sum of the volume of the constituent gases. So this is the sum of the volume of gases, V1 plus V2 plus V3 plus N is going on. So as previously Dalton's law of partial pressure, we can see according to the ideal gas equation, there are so many volumes occupied by the gases V1, V2, V3 up to N. So most of the N1 gases RT by P because temperature is constant. Most of the gases occupied by the second gases V2, N2, RT by T, V3 will be N3, RT by V. V1, V2, V3 are the different partial volume of the gas in which temperature pressure is constant. So total volume will be, just add it all this way, partial volume. So on adding, so this N1, N2, N3, just take it out. RT by P is a common value. This becomes summation of N into RT by P. Now V1 is N1 by RT by P. So this is N1 RT by P, and here total is delta N RT by P. So we can write eliminate RT by P in common to them. So V1 equal to N1 RT by P. So this equal to RT by P is equal to nothing but this one VT by delta N. So VT by summation of N, V1 by N1. So this is V1 by N1, RT is eliminated out. So we can write V1 equal to, this will go up to N1 by summation of delta N into total T. So this is nothing but it becomes your partial volume of gases equal to, this is the partial volume gas, this is equal to mole fraction of gas into total volume. So this is the equation for this Amagat's law. So I have given one problem. See this problem, how this solution can be, how we can get these solutions. A mixture of nitric oxide and NO2 was analyzed by selective absorption of the oxides of nitrogen. The initial volume of the mixture was 2.74 cm cube. After treatment with water which absorbed the NO2, the volume was 2.02 cm cube. A ferrous sulfate was then second with the residual gases, after which the volume was 0.25 cm cube. All volumes are measured at same pressure and temperature, neglecting water vapor. What was the volume percent of each gas in the original mixture? So it is very initially there were volume mixture was 2.73 means 3 mixture is there. If you absorb NO2, you will get 2.02. So NO2 means if you subtract this one, you will get the partial pressure of nitrogen and NO2. So again, if you take a pair sulfur solutions, so residual mass after which the volume becomes 0.25 cm cube. So we can solve this one. So you know this NO2, then you can solve N2 plus NO2. So after solving N2 plus NO, you will get this percent. So I am not solving this problem. You try it, you will get this answer. So I have given answer here. Partial pressure of nitrogen 9.12, partial pressure of nitric oxide 64.6%, and partial pressure of nitrogen oxide 26.28%. So using the Amagat's law, you solve it, you will get these answers.